Okay. So Laplace is somebody you all know. And he just says that probability theory is nothing but common sense reduced to calculations. And this is something which I found very striking, and so that's exactly what it is. So you just have to have some common sense, and coupled with that common sense, you have to be good in calculations. ये दोनों चीजें ठीक हैं, तो फिर you're going to be good at probability. So that's what probability theory is. Now let's begin with some simple definitions, and these definitions are things that you will most likely be familiar with. So I'm going to quickly go over them. So the first definition I have for you is random experiments. So what is a random experiment? A random experiment is simply an experiment whose outcome is something that you cannot predict, right? So you cannot predict with certainty. And the simplest examples that you can think of is just tossing of a coin, जो कि शायद undergraduate studies में आप सारे करते रहे हैं, or drawing of cards, or throwing of a dice, right? But it's actually much more than that. I mean, anything that you can think of which is uncertain can be classified or categorized as a random experiment. So it is not necessarily something that you do with your hands. That's an experiment. Experiment can be something else. For example, the experiment could be, I run an experiment and just try to figure out when does LUMS open. Okay, so that's an experiment whose outcome is unpredictable in terms of kab khulna hai, kab nahi khulna hai, I cannot really predict, right? So that's a random experiment. I run an experiment every day in the class and try to figure out the roz class mein kitne bache aate hain, right? That's an experiment I run at the beginning of the class, and then I just see how many people show up. That's a random experiment as well, right? So other examples could be, or flipping of a coin, or drawing of cards. This I'm going to skip over and maybe come up with. So it's a number of people in class, students in class. So that's a random experiment. Or your grade at the end of the semester, right? So that's a semester-long experiment, if you will. And that's a random experiment in the sense you cannot predict with certainty what your grade is going to be, okay? So that's also a random experiment, and so on and so forth. I mean, whether you get an A or not. So that's another kind of an experiment which is related to the grades, but the outcome is binary. Either you get it or you don't get it, but that's a random experiment, okay? That's something you cannot predict, okay? So the other definition I have for you is outcomes. So outcomes क्या होते हैं? Anybody who can tell me what an outcome is?
The result of the experiment.
The result of the experiment, right? So so as a possible result of an experiment. And I mean, I need not go further. I mean, all of the examples that I mentioned, उसकी जो outcomes हैं, either you get an A or don't get an A. That is an outcome of the experiment, okay? What about something called the sample space? What's a sample space? Ji Zain, what's a sample space? Ji Shoaib ने हाथ खड़ा किया हुआ है. Is there a question? Yeah.
No, sir. I had the answer. If I
answer, ठीक है. Go ahead. Shoaib, go ahead.
So sample space is all possible outcomes of the experiment.
Right. So we define the sample space as a set, right? So this is a set of all possible outcomes. And we typically denote that by an alphabet S, okay? So for example, when you're rolling a die, the sample space क्या होगी? Sample space is going to be just the collection of all possible outcomes, which is either you get a 1 or a 2 or a 3 or a 4 or a 5 over 6, right? So that's one example. But what if you're rolling 2 dice, right? You roll 2 dice.
36
What is the sample space there?
और 36 तक होंगे वो
36 तक होंगी? What do you mean by that?
सर 1 भी हो सकता है 1 2 भी हो सकता
Okay,
है
so the outcomes is going to be in the form of ordered pairs.
पेयर्स
Right?
होंगे
We thought 36 possible outcomes. So the sample space here for that 2 dice is going to be 1 1 1 2 all the way up to 6 6. Okay, and mind you, 2 comma 3 is not the same outcome as 3 comma 2. Right? They're distinct from each other. Okay, because the first corresponds to the first dice and the second outcome corresponds to the second dice. So 2 comma 3 is not exactly the same as 3 comma 2. Okay, so this is for the case of this is for the case of 2 dices. So 2 dice, and this is for the case of 1 dice. Okay, and then I have something called the events. Events क्या होते हैं? Events क्या होते हैं गाजी?
A subset of sample space.
I'll agree.
फिर से बताइएगा. I didn't hear the first response. So Ghazi, say it again.
So a subset of sample space.
A subset of sample space. Okay. So and Ghazi agrees. So event is simply a subset of the sample space. So for example, so when throwing a die, so you can say A is an event, which is what? Which is that the outcome turns out to be odd. So the outcome is odd. And that's an event. That's a subset of the sample space, right? It's a subset of the sample space. And there could be many, many others. So what's the relationship between an outcome and event? So an outcome is an event, right? And an event may be a collection of outcomes. Okay, so it's a subset of the sample space. Okay, so that's an event. So for example, and another example, so example 1, example 2, so when throwing 2 dice, some events could be that A is the event that the sum of the outcomes is equal to 6. Okay, so इसके अंदर वैसे, by the way, what outcomes will this event include? That when you throw 2 dice, right, the sum of those 2 outcomes on those 2 dice turns out to be equal to 6. So what are the possible outcomes which will result in a sum equal to 6?
The 2 4 4 2.
Yeah, so okay, so I will start with here, so 5 1, okay, and then 4 2, then 3 3, then 2 4, and then 1 5. So these are 1 2 3 4 5 possible outcomes which results in an event. So either one of these outcomes happens, and you're going to say, Kitty, the event A has actually happened. Okay. All right, and then many other examples. So this is example 2. Let me give you a third example. So when you say S of t equals a cosine 2 pi sum f naught t plus theta. So what I'm saying here is, okay, let's say you have a crystal oscillator in your lab, and you know for sure that the crystal oscillator oscillates at a frequency and gives you a pure sinusoid and oscillates at a frequency of f naught hertz, right? So that's something you know for sure. Even though इसमें randomness typically होती है, noise को होती है, but let's assume that's something you know for sure. Even if you do, even if there's no noise, the phase is always going to be random, right? You start an experiment now, you start an experiment tomorrow, like the phase that you're going to get in that sinusoid is not going to be the same. The phase is something that you won't be able to predict. Okay, the phase is going to start out at something which is random. Up is phase key. So we say that the theta is random. We say that this theta is random or uncertain, right? So what do you think is the sample space going to correspond to for this particular randomness? When I say the experiment जो है वो theta के ऊपर है, right? First off, the experiment is on theta, and when I do the experiment, theta takes on some value. What is the sample space? D. Shoaib, you raise your hand.
0 to 2 pi.
0 to 2 pi. Good. So sample space here S is a set, is a which takes on continuum of values between either 0 to 2 pi or typically हम जो है minus pi to pi तक लेके जाते हैं, right? And this is an open set. Why is this an open set? I mean, why is this open here?
Because cosine is periodic, so the value at 2 pi will be the value at 0.
Yeah. So exactly. So essentially, basically, the phase is modulo 2 pi. So the phase of minus pi is actually exactly the same as the phase of pi. ठीक है, तो हम जब भी phases लिखते हैं तो you recall DTFT as well, right? So you always define between minus pi and plus pi, but open at one of the ends, ठीक है, and close from the other. So that's the sample space. And event could be possible event could be, oops. So a possible event here could be so A is the event that when you do the experiment, the theta turns out to be equal to a value which is less than pi by 4. The absolute value for that is less than pi by 4. Okay? So that's an event. Okay, and you could have many more. Ji Shoaib, you raise your hand.
Yes, sir. So I have a question. So if A is random, then this sample space that you have written, it may not be an open set, isn't it?
You see, so first of all, so you're saying theta is random, right? If theta is random,
Yes.
so here the sample space is going to be an open set. Why? Because minus theta actually corresponds to plus, is equal to plus theta. They're exactly the same.
Yes, but if A is random, A is also random.
Yeah,
and theta is random.
amplitude की.
जी मैं amplitude की बात कर रहा हूँ.
Okay.
Amplitude भी random है और theta भी random है.
Yeah, even then, so theta is another experiment and the amplitude is another experiment, right? And the amplitude and the phase are independent of each other. Recall that. Okay, they're different quantities. The amplitude does not affect the phase of a sine, of a cosine. So theta की particular definition है, which corresponds to particular phase, particular amplitude. Okay? So they're independent of each other and have no dependencies as of yet. Okay. So then I want to quickly move on to axioms of probability. Okay. So the question here is, what is probability? I mean, how do you define probability? I mean, chale, define me. I mean, what do you understand probability to be?
If we have if we perform an experiment and the outcome is always different,
Yeah.
with probability, we estimate that given a large enough sample size, the results will converge to the different probabilities.
Okay. Okay.
So
So,
likelihood of outcome.
so there are two dimensions to this, or two interpretations to this. And actually, Isha and Ghazi actually pointed out to the two different dimensions of probability. The first dimension, which is sort of the Bayesian perspective, that probability is the likelihood of an event, right? So if I do an experiment, if I know that the certain outcome is more likely, I am going to assign a number to it, which is the probability, which is going to be higher. The more likely an event is, the more higher the probability should be, because probability corresponds to the likelihood of an event happening. The probability of an event corresponds to the likelihood of that event happening, or the chances of that event happening. Okay? So for example, if you flip a coin and you say that the probability that the coin lands on a heads is 0.8, what you're really saying is that there's an 80% chance that or 80% likelihood, is very likely, it's more likely, 80% likely that the coin is going to land on its head. Okay? So that's the likelihood perspective, or the Bayesian perspective. And the other perspective is, which is the relative frequency perspective, right? And both are actually the same. And that relative frequency perspective is what Ghazi pointed out, which is if you perform the experiment over and over again, right, infinitely many times, and you count the frequency with which the event of interest happens, and you take the ratio of that to the total number of experiments, that ratio is going to converge to something called the probability, which corresponds to the likelihood of that event happening. Okay? So both interpretations are similar, right? So in general, we say that probability is actually a number, right? And the likelihood of an event is being mapped to a number. The more the likely that event should be, the more this number should be as well. Okay? So the relative frequency approach. Okay. Right. So the relative frequency approach is what? The relative frequency approach is just says that you count the number of times an event A has happened, right? So you say the probability of A, where A is an event, is approximately equal to the number of times and the event A has happened divided by the number of experiments. Okay? Okay. Right? So where this is, n is the number of experiments, and NA is the number of experiments in which event A occurred. Okay? And we know the probability of A is defined as the limit n going to infinity NA divided by n. So as a starting point, for me at least, this relative frequency approach is what I believe the probability to be, which is that if I wish to make sense of what a probability of a certain event is, I think of it in the sense if I were to do this experiment over and over again, infinitely many times, and I compute the relative frequency, that relative frequency is going to be equal to the probability, is going to correspond to the probability of that particular event. But the probability itself, another way to think about is कि जी probability असल में एक कोई inherent चीज है, right? एक innate quality है उस experiment की, right? And it is that innate quality of that experiment that you're actually trying to estimate through this relative frequency approach, right? Even though the both are the same, but the interpretations may be slightly different, right? And the way I see it as कि सबसे पहले मैं अगर सोचूं probability के बारे में, which would be कि this relative frequency approach, ठीक है? So that's easy to understand. But then the next level would be कि the probability of a certain event is actually some innate quality of that random experiment, right? And it which tells you about the likelihood of the event, which tells you something about the chances of that happening, and a way to estimate that chance, the way to estimate that likelihood is through the relative frequency approach. Okay? Whatever interpretation you follow, all of the axioms of probability that we're going to do next, all the rules, all of them stay the same. Okay? One may be beneficial of the other in some advanced courses though. Okay? As far as we're concerned for this course, both are similar. So if you just stick with the relative frequency approach, that's fine. Okay? All right. So what are the axioms themselves? So the axioms, the first axiom is that the probability of any event A is always going to be greater than or equal to 0. Okay, and that's pretty straightforward. The axiom 2 is going to be और क्या जेन में आता है axiom? Anybody?
So the probability will always be less than 1.
Okay, so the probability will always be less than 1. Actually, जो axiom है उससे related है, लेकिन जो less than 1 वाली चीज़ है, you can derive from the axiom. The axiom is that if Mars, just give me a minute. Okay, Mars. If S is a sample space, then probability of S should be what?
1.
Should be 1. Okay? So in other words, what is the probability that the sample space occurs? That makes sense. That probability is the highest value that there could be. The highest chances that it's completely certain. And that probability is equal to 1. Okay? All right. And then we have axiom 3. And that axiom 3 is that if A intersection B is the null set, what does that mean? That there's no commonality between the two events A and B. Okay? Then probability of A union B, what is S equal to?
Probability of A plus probability of B.
So the probability of A union B in that case is equal to probability of A plus probability of B. So these are the 3 axioms. And this axiom 3, in fact, can be extended. So can be generalized. How? So I say कि if A1, A2, dot, all the way up to AN are mutually exclusive, what do I mean by mutually exclusive?
The outcome of one does not depend on the other.
No. So when you say dependent, so when we have a very, very different notion of
Oh,
dependence.
that's independent events.
Ji Shoaib?
If one occurs, then the other can't occur.
If one occurs, the other can't occur. And in terms of sets, what that means is there's nothing common in between them. Okay? So what it actually, when I say two sets are mutually exclusive or two events are mutually exclusive, what I really mean is that if I take any event A sub I and find out the intersection of that event with another set A sub j, this is going to turn out to be equal to the null set for all I is not equal to j. Right? So the exception, of course, is when I equals j. When I equals j, this is not the null set. Right? But when these two sets are different or two events are different, then if I take the intersection of this set, no matter what I is, no matter what j is. Okay? If I take the intersection, if this intersection turns out to be the null set, we say that those sets or those events are mutually exclusive. And if this condition is satisfied, so then probability of union I equals 1 to sub a sub I, ये किसके बराबर होगा? This
1.
will be equal to the sum of the probabilities. ठीक है? All right. Is this clear? So all I'm saying is, if there are many, many sets, many, many events, but all of these events are mutually exclusive, if I find the probability of the union of all of these events, the probability of the union of all of these events is just simply equal to the sum of the probabilities of these individual events. Okay? And that the fundamental axiom essentially really is this thing here. ये असल में fundamental है. Okay, this is the fundamental axiom. And this in green thing can be derived from the one above. Okay? Through किस तरह करेंगे ये उसको क्या कहते थे? I forget. Right, so you go one after the other. पहले 2 से करे, फिर 3 से करे. You have n to n plus 1 पे जा सकते हो. ठीक है? क्या कहना है शोएब उसे यार टेक्निक को? चलें. So never mind. Okay. And some important properties that you can derive. So important properties कौन सी हैं? The first property is that the probability of A complement is equal to 1 minus probability of A. Right? And this actually can be derived from induction. Thank you, Shoaib. Right. So Moaz also tells me induction. Very nice. Okay. So the probability of A complement is equal to 1 minus the probability of A. Right? Can you derive this from all of the axioms, from the 3 axioms that I stated above? So I'm not going to derive it here, but I'm just asking, any ideas how we can do that? Yes, Shoaib?
So I think it can be derived from axiom 3 and 2 because 3 says that probability of A plus B and it's equal to 1. So if you bring one probability to the other side, you come up with this.
Okay. So it's actually axiom 2 and axiom 3. So you start out with the sample space. You know that the sample space is equal to the union of A and A complement. And A and A complement are mutually exclusive. So the probability of, so I'm doing this here like in Chile. So probability of A union with A complement is equal to the probability of A plus probability of A complement. Why? Because A and A complement are mutually exclusive, right? But this thing here is nothing but the entire sample space S. Therefore, this must be equal to 1. And this completes the proof. And so probability of A complement is just 1 minus probability of A. Okay? Another property that you can derive is that the probability of phi is going to be equal to 0. Okay, property 1 से निकल जाती है, right? Because phi is a complement of what?
This complete sample space.
The entire sample space. Good. Which is the entire universe, right? So remember, the sample space is the entire universe as far as your experiment is concerned. Okay. And then the third property is that the probability of A1 union with A2, what is this equal to?
Probability of A1 plus probability of A2.
Okay.
Minus the intersection.
So it says the probability
Yes.
A1 plus probability of A2. That's not necessarily true, because nowhere have I told you that the two
That this
events
joint
are mutually exclusive, right? If they're
Sir.
not mutually exclusive, you have to have something else here. Which is,
minus probability of A1 intersection A2.
okay, and this is once again something that you can derive from the all of the axioms above. Okay, this is something you can derive. Okay, and try to derive this. I'll be available for answering any questions or any difficulties you may have. ये भी निकल जाएगा आराम से. You just need to somehow describe sets in some way जहाँ पे mutual exclusivity भी आ रही हो. ठीक है? And by the way, this, remember, this reduces to axiom 3 when A1 intersection with A2 is a null set, right? So this last term is going to go away, right? And so this is actually a generalization of axiom 3, if you will. Okay? Acha. The fourth property, which is the final property, is that if A1 is a subset of A2, then probability of A1 or probability of A2, how do they compare? So there's an inequality here. Giuseppe?
So probability of A1 will be less than equal to the probability of A2.
Good. Will be less than equal to. Good. Okay? And this can also be derived from the 3 axioms above. Okay? I mean, you may think, yaar, this is a fundamental axiom. This is not a fundamental axiom. वो 3 axioms ऊपर है. उन 3 axioms से ये सारी properties derive हो सकती हैं. So all of these properties are actually a consequence of the axioms that we were described above. ठीक है? और मैथ्स सारी की सारी by the way यही होती है कि आप you define some fundamental rules और बाकी सारे rules उससे निकलते हैं. Right? In that sense, for example, मैथ्स में division कुछ नहीं होती. मैथ्स में सिर्फ multiplication होती है. Right? And division is a consequence of multiplication. ठीक है? All right. So I'm not going to do a proof for these here. However, I encourage you to so try the proofs yourselves. Okay. So next, what we're going to do is some probability building blocks. Any questions so far? So far, so good, right? So far, easy. मसा नहीं है. All right. So So how do you define a joint probability? So let's say I gave you two events, right? So I give you events A and B. So given events A and B, how do you define the joint probability of the event A and the event B? उसका मतलब क्या है? Anybody? जी हुज़ैफा आपने अनम्यूट किया है.
इनका इंटरसेक्शन इन्वॉल्व हो रहा होगा इसमें.
ओके, सो इंटरसेक्शन
yes,
इन्वॉल्व तो हो रहा होगा उसको, लेकिन अगर आपने जैसे देखें, आपने एक्सप्लेन करना है किसी को, फ्रेशमैन को एक्सप्लेन करना है, अभी फ्रेशमैन को पढ़ाना है आपने कल, तो अगर फ्रेशमैन को आपने एक्सप्लेन करना है यार कि व्हाट इज द जॉइंट प्रोबेबिलिटी, उनको पता है इवेंट्स क्या होते हैं, फिर तो
There is something common in between set A and B.
जी मुनीबा फिर से कहिए.
Probability of
मुनीबा
So कुछ common है, like in set A और set B के अंदर कुछ common thing होगी, तो हम उसकी जो probability find करेंगे उसको joint probability कहते हैं. Like A intersection B.
Okay. So
A and B.
I think of this
A
in
और B
terms
के
of,
इकट्ठे होने का.
of things happening. देखिए एक आपने रैंडम एक्सपेरिमेंट कर रहे हैं और रैंडम एक्सपेरिमेंट हो रहा है एंड मोहम्मद खालिद हैज द राइट आंसर हियर कि द प्रोबेबिलिटी और द लाइक्लीहुड that the two events occur simultaneously, right? Not only is the conditions corresponding to the event A satisfied, but also those corresponding to event B, they are also satisfied. Both of them happen simultaneously. The likelihood of that happening is a joint probability of the event A and B. And let me give you some examples. So joint probability of A and B, so is the probability of the two events occurring simultaneously, which actually corresponds to an intersection. ठीक है? Simultaneous का मतलब intersection है. So in other words, we denote this by P, A, comma B. So from here on, whenever you see two arguments inside the probability function, that will mean that I'm talking about the joint probability of those two events. And we're going to generalize this to random variables later, right? So probability of A comma B is defined as probability of A intersection B, right? Or by the way, ये इसका क्या मतलब होता है? This is a definition, right? इससे पहले मुझे probability of A comma B का नहीं पता था, सिर्फ intersection का पता था, ठीक है? So from here on, the notation probability of A comma B means that it actually is corresponds to probability of A intersection B. Okay? So let's do an example here. Oops. So जो technical difficulty थी वो ये थी कि I had all the colors set up ताकि मैं स्क्रीन पे ब्लैक हो और जब मैं आपको नोट्स दूँ तो वो वाइट पे आ जाएं स्क्रीन इन्वर्जन के थ्रू, लेकिन वो फॉर सम रीजन Zoom is not inverting that screen, so I had to go back to the backup option. अभी देखें फिर आगे, I need to figure it out. So example, so let's define two events. The event A, मेरे नोट्स में जो इवेंट है वो PTI सपोर्टर और 30 years of age वाला है. Youngsters support PTI, others don't. Let me go back to a traditional. This is ये पुरानी एग्जांपल थी जब इलेक्शंस हो रहे थे, लेकिन let me go back to a traditional example. So A is defined as the event that a person has heart disease. And let me define the event B as a person is less than 40 years of age. right? Now these two events are measuring different things, right? So you measure, so basically the experiment that you're performing is what? You have a population, right? And amongst that population, you draw somebody at random, right? And when you draw somebody at random, you check whether that person has heart disease, right? If that person has heart disease, that's an event A. If that person is above 40 years of age, that's the event B, okay? And what is the probability of A comma B, or the joint probability of A and B? That is a probability that the person that you pick at random not only has heart disease, but is also above 40 years of age. Okay? That's what this joint probability is going to correspond to. So this is defined as the probability or the likelihood or the chances that a person has heart disease and, so this is important, and is greater than 40 years of age. And this, by the way, this number is quite high for less than, okay, so मैं इसको greater than कर देता हूँ. Thank you. Okay, and this, by the way, this is quite high for the South Asian population, right, as opposed to Caucasian population. Okay, so there's something in the genetics, or maybe something in our food, जो निहारी हम खाते हैं ना सारी, that acts up. Okay, so in terms of a Venn diagram, if I were to represent it as a Venn diagram, what would this look like? This is going to be, I will have a certain sample space, which is the entire population. And within that sample space, I am going to have a set. I am going to have a set which corresponds to the event A, right? So this is the event A, which means that the person has heart disease, right? And then there is going to be another set which corresponds to the event that the person that I pick at random is greater than 40 years of age. Okay, that is the event B, right? Or the set B. And probability of A in this case is approximately going to be equal to what? Is, if I just talk about the entire population of, for example, Pakistan, or my area of interest, region of interest, then this is going to be the number of people who have heart disease divided by the total population of that sample. Okay? What about probability of B? Probability of B using the relative frequency approach is going to be N. B is the number of people above 40 years of age divided by the total population. And finally, what will P of A comma B be equal to? This will be the number of people who have heart disease and who are above 40 years of age divided by the total population size, right? So essentially, this is the area that you're going to be looking at, right? So this is what A intersection B is. Okay? And you can have many other examples. The probability that you get an A and you spend more than 9 hours a week on this course. Okay? The rule, by the way, the rule of thumb is what? 3 credit hour course का क्या मतलब होता है? 3 credit hour course means that's 9 hours of work a week, right? Every week, on average, right? But the average should not be skewed. I mean, the distribution should not be skewed. I mean, if you're just studying towards the finals, that so it's good. And there are many other examples. I will urge you to look at a particular example in the textbook, which is, let me see, example 2.11. And that's really helpful in the textbook. Okay. All right. So now once we have the notion of joint probability, then there's a notion of conditional probability. So what is a conditional probability? Have you studied conditional probability before?
Yes, sir.
हाँ जी, ज़ैफ़ा के साथ क्या पढ़ा है?
So basically the likelihood of an event occurring given that some other event has occurred previously.
Okay. So probability of A given B. So this is a notation that we're going to use, right? So A slash B, or I'm going to read it as probability of the event A given the event B. And what this means is, or what this corresponds to, is the probability that the event A happens given that the event B has already happened. Okay? So this is the probability or the likelihood of A given that B has happened. So which in the example above, what that means is the probability that you have this heart disease given that ये क्या था, is greater than 40 years of age. So essentially, if I just go back to the previous example where this 40 years and heart disease वाली जो example है, so the probability of A given B would actually mean what is the probability that a person has heart disease given that that person is above 40 years of age. So in other words, when you're talking about conditioning, you're reducing your attention to a subset of the sample space. Okay, when you say some event has already happened, so you're not looking at the entire sample space anymore, right? But you're rather concentrating your attention to a reduced set or a subset of the sample space. Okay? And how does this relate to the joint probability? Here's how it relates to the joint probability. So probability of A, if I go just back to the previous example here. Oops. So what is the probability of A comma B, A given B, for the previous example is going to be equal to what? Is approximately going to be equal to B already occur ho chuka hai. So you're within the set of people who have who are above 40 years of age. And within that set, you're interested in finding iske andar what is the likelihood of having heart disease, right? So this is going to be equal to N A comma B divided by what? NB. Right? Is that clear? So you're already inside the set B. You're already inside the set B here. You're already inside the set B here. Right? And inside the set, you're saying कि जी इसमें से कितने लोगों को heart disease है? कितने लोगों को heart disease है वो इधर होंगे? Right? Which is just equal to N A comma B. Right? And then you take that ratio in terms of the relative frequency approach of the total number of people inside the set B, which is NB. Okay? So if I expand this slightly. So this is n a comma b. I divide by n in both the numerator as well as the denominator. Right? So what do I get in the numerator then?
Probability of A intersection B.
So the numerator is probability of A intersection B, or the joint probability of A and B. Okay? And the denominator is just the probability of B. Right? So this is the relationship between conditional probabilities and joint probabilities, right? So let me rewrite this here again. So this is, so probability of A given B is equal to probability of A comma B divided by probability of B. So this is of course not a formal proof. This is just some hand waving thing that, or intuitive explanation of what this is. I'm not going to do a formal proof here, but this is what it is. The conditional probability of A given B, or the conditional probability of A given B, is equal to the joint probability of A and B divided by the probability of B. Okay, so this is a rule or a fact that we're going to keep on using throughout the semester, throughout the course. Okay, let's do an example for this now. So example क्या है? Consider throwing of a fair dice. Okay, and the event A that I am interested in is that the outcome is greater than 3. So this includes what outcomes? This includes 4, this includes 5, and this includes 6. Okay? So either one of these 3 outcomes occur, that's the event A. Okay? The event B, on the other hand, is that the outcome is even. Outcome is even, and that is 2, 4, 6. Okay? So what is the probability of A comma B, or the joint probability of A, B? What I mean by that is, when you throw a dice, what is the probability that the outcome is not only greater than 3, but is also even? What is this going to be equal to? This is equal to the probability of A intersection B, right? And this is the probability of what set?
So just by observing, we can see that 4 and 6 are common in both of these.
4 and 6,
so,
exactly. So that's the intersection. So numbers that are not only even but also greater than 3 are 4 and 6. That's the event that you're interested in. The intersection of event A and B is this event, that either a 4 occurs or a 6 occurs. And the probability for this is what? It's 2 by 3. Okay? What about probability of A क्या है? That's half. What about probability of B? That's half as well, right? So what is probability of A given B? A given B का क्या मतलब है? सबसे Maz, you can unmute yourself. After I speak, तो A comma B given B का क्या मतलब है? The probability that when you throw a dice, आपको कोई बता देता है कि यार outcome even आई है. Right? You know for a fact that the outcome is even. You don't know what it is. You just know that it is even. Right? And then somebody asks you, okay, if you know that the outcome is even, what is the probability that outcome is greater than 3? Okay? That's the conditional probability that you're interested in. Okay? Acha, Maz, go ahead.
सर ये जो आपने जॉइंट प्रोबेबिलिटी पर फाइंड की, ये 2/6 नहीं होगी, 2/3 लिखा हुआ है ना? तो सैंपल स्पेस में तो 6 है एलिमेंट्स.
Sorry. Yep. So this is 1 by 3.
3.
ठीक है गाजी, ये कहना था.
Yes, sir.
Fine. Thank you. Thank you. So that's 1 by 3, right? So once again, the probability of A given B is what probability is somebody tells you that somebody has rolled the dice and the dice shows an even number. You don't know what that even number is. And you're asked to find what the probability of that number being greater than 3 is. That's the conditional probability that you're interested in, right? And just by going by this rule here, or this rule here. So what is this equal to? This is equal to the probability of A comma B divided by probability of B, which is going to be equal to what? This is 1 by 3 divided by 1 by 2, which is nothing but 2 by 3. Okay? Is there another way you could have thought about this, by the way? I mean, this is just using the formula that I mentioned. I mean, I don't like you use the word formula here anyway. लेकिन चलें एक formula अगर मैंने आपको दे दिया, you just apply the formula and you find out that the probability, the conditional probability is 2 by 3. Okay? Is there some other way you can think about this?
You could look at, we know that B already occurred now.
Yeah.
So B is our sample size. It's the new sample size.
Yes.
Just look which number is greater than 3. The 2, 4, and 6 are greater. So 2 by 3.
Good. Right? So B has already occurred. So that means your sample space has reduced from 1, 2, 3, 4, 5, 6 to 2, 4, and 6. ठीक है? आपको कोई कहता है even number आया है, तो you know for a fact कि जी either it's a 2 or a 4 or a 6. Now I need to find out what the probability of me getting an outcome which is greater than 3 is, given that either a 2 occurs or a 4 occurs or a 6 occurs. And then within these 3 possibilities, there are only 2 numbers which are greater than 3. And therefore, the probability, in this conditional probability, is going to be equal to 2 by 3. So that's another way you can think about it. ठीक है? Which actually यही हो रहा है. Probability of A comma B divided probability of B असल में यही कर रहा है. Okay, if you go by the relative frequency definition. Okay, any questions here? Okay. So we're going to come to more interesting examples maybe in the next class. I just need to get these definitions out of the way. So the next thing I want to talk about is statistical independence. So we say that 2 events, so independence is a property of a lot of other things, but statistical independence, first off, at the starting point, we're going to say it's a property between associated between 2 events. Okay? So we're going to say 2 events are statistically independent when something is satisfied. Okay? What does your intuition tell you? When I say whenever I say there are 2 events, and those 2 events are statistically independent, ज़हन में क्या आता है?
Sir, that the outcome of one does not affect the outcome of the other event.
Okay. When you say the outcome of one does not affect the other, affect से क्या मुराद? क्या चीज़ affect नहीं करती उसकी?
The probability of the occurrence of the other event.
Good. Right. So the probability को affect नहीं करती. So that's great. So we say, and that's what your intuition tells you as well. Okay, if there are 2 events that are given to you, A and B, those 2 events are going to be statistically independent when the occurrence of one does not affect the chances of occurrence of the other. Or in other words, it does not affect the probability of the occurrence of other. So the definition is that events A and B are said to be statistically independent. If occurrence of one does not affect the probability of the other. Right? Mathematically, what does that mean? So mathematically, this means that the conditional probability of A given B, if those two events are statistically independent, this must be equal to what?
Probability of A.
Probability of A. And probability of B given A must be equal to
Probability of B.
probability of B. ठीक है? अच्छा. And you can actually verify that this implies, and actually this implication is both ways, that the joint probability, what is this going to be equal to?
Probability of A multiplied by probability of B.
Probability of B.
Good. Right? Why is that? And the reason why that's true is because probability of A comma B is probability of A given B times probability of B, right? But probability of A given B is just probability of A. So this is just probability of A times probability of B, right? So this is more widely used, by the way. And this is something that people start out with often as well, which is, KG, I'm going to say two events are statistically independent if the joint probability of those two events is equal to the product of the probabilities of those two events. If that's satisfied, then we say that those two events are statistically independent. Okay? Here's a question here, or a trick question, if you will. If I give you two events that are mutually exclusive, and this is something that people, students often confuse. They think of mutual exclusivity as independence. So they think of both of these things to mean the same. अक्सर पूछा जाता है mutually exclusive का क्या मतलब है? Independent है. और independent का क्या मतलब है? Mutually exclusive है. That's not true. So if I give you two events which are mutually exclusive, can you say something about their independence?
They cannot be independent
They cannot be independent. Why?
because mutual exclusivity का मतलब हमने देखा है कि बिल्कुल आपस में related ना हो किसी भी sense में.
Yeah.
On the other hand, independence says that if one is occurring, the other will not be affected by it.
You said that I need a more crisp answer.
So I was saying that if two events are independent, it means that one does not affect the probability of other, but the other event can still occur.
Yeah.
So it means that if two events are independent, they can or cannot be mutually exclusive.
So actually, I go the other way around and say, if two events are mutually exclusive, they can never ever be statistically independent. And think about that, right? Why? Because if they're mutually exclusive, I know that if one of them has happened, the probability of the other happening is 0. Because there's nothing common in between them, right? So there's mutually exclusive, there's intersection is 0. The probability of A given B is 0. Right? If they're mutually exclusive, but the probability of A may not be 0. Okay? So think about this. I'm not going to write this in the notes as well. You can think about this here. What I claim is that if two events which are not the null events, if those two events are mutually exclusive, they cannot be statistically independent. they cannot be statistically independent. Okay, which basically means if they're statistically independent, they cannot be mutually exclusive. Okay, so think about that. So this idea of independence can be extended to multiple random variable, multiple events. If there are 3 events, right? This can be generalized. You can find the generalization in the textbook. If there are 3 events, A, B, and C, then those 3 events are statistically independent if probability of A comma B is equal to the product of these 2 probabilities, probability of A comma C is equal to the product, and probability of A comma B comma C is also equal to the product. So there are 3 conditions that need to be satisfied. Okay? And you can find a more generalization to more than 3 events in the textbook as well. I'm not going to write them here. It's pretty straightforward. Okay? Okay. So there is, how much time do I left? I have 4 minutes left. So let me just quickly do one last thing. This is theorem of total probability. So is this something you're familiar with? Who's familiar with this? Theorem of total probability, or sometimes also called the total law of probability. कौन familiar अभी? Okay. So Ghazi raises his hand. तो बाकी सारे ये शोएब हुज़ैफा, you should be familiar with it. है ही नहीं है?
हमसे exactly definition याद नहीं आ रही sir.
Okay. What about the graduate students? Salar, are you familiar with the theorem of total probability?
Sir, as far as I can vaguely remember, I think it was like event happening and not happening,
Okay.
some that both are.
Okay. So let's discuss this. Okay. So let B1, B2, all the way up to B sub n be mutually exclusive and exhaustive events. So mutually exclusive, we've actually found out what it is. Mutually, or any mutually exclusive. Maha, do you have a question?
No, so you asked us now that if we had an idea of law of total probability or not. So I answered that question.
Okay.
That I had an idea.
Okay, that's fine. Ali Zain, do you have a question or ये पहले का हाथ खड़ा है?
पहले किया था law of probability के लिए.
Right. So mutually exclusive की definition क्या है? कि Bi intersection with Bj must be equal to the null set for all I is not equal to j. What about exhaustive events? Exhaustive events का क्या मतलब होता है?
They cover the whole sample space.
They cover the whole sample space. If I take the union of all of those events, I'm going to get the sample space, right? So what that means is, if I can give you a graphical depiction or illustration of with some small n. So let's say this is how the sample space is divided. Okay, so this is B1, this is B2, this is B3, this is B4, right? All of these sets are mutually exclusive. In other words, they don't have anything in common. The intersection is 0. And they are exhaustive. In other words, if I take the union of all of them, I'm going to get the sample space. Okay? अच्छा, इसके अंदर if I एक set A बना देता हूं अगर मैं. So this is set A, right? So what is this equal to? This is A intersection B1, right? What about this thing here? What is this equal to? This is A intersection B2. What about this thing here? This is A intersection B4, and finally this is intersection B3, right? So can I write the set A as some function of all these intersections for this particular case? Kya hai, Ghazi? So you shake your head.
It is the sum of the intersections.
Is the union of all the intersections. Okay? I'm assuming that by sum you meant union. So this is A intersection with B1 union with A intersection B2 union, and so on and so forth. And let me just generalize this. So this is B sub n, right? And all of these sets are mutually exclusive. Ye, all of them are exclusive, mutually exclusive, as you can see in this example here as well. And that's from set theory. Okay? वो सारे B's अगर mutually exclusive हैं, उनके intersection भी mutually exclusive होंगे. ठीक है? So then, if they're mutually exclusive, how can I write probability of A? That can simply be written as a sum. Okay? That comes in from one of the axioms that we defined earlier. Right? If they're mutually exclusive events, the probability of that union is just equal to the sum. Okay? And this is equal to I equals 1 to n probability of A comma B1 BI, sorry, right? And this implies that probability of A equals I equals 1 to n probability of A given BI times probability of BI. And this is the total law. However, for this B1, you just keep in mind, they have to be mutually exclusive and exhaustive. Okay, so this is the total law of probability. इसकी applications क्या हैं? This is something we're going to see in the next class, hopefully. Okay, so we're going to stop here. Any questions? Yes, Shoaib.
Yes, so coming back to the case that A cos omega t का, when I look back now, so it doesn't make sense कि जो theta जो है और क्या कहते हैं A जो है अगर दोनों साथ random variable हो, because then our function would not be periodic. तो हम क्या कहते हैं theta की जो है वो sample space बता ही नहीं सकते. But doesn't this tell us कि A and theta are actually dependent?
Not really. So देखें, nowhere did I write A to be a function of time. ठीक है?
But changing A will definitely.
At the same time, I did not write theta as a function of time, right? So even if A is random, so the amplitude is random, and if the theta is random, even then when you perform an experiment, the outcome that you get is still going to be periodic.
Okay, so even if they can be both random, but they're not functions of time.
Yes.
So they can be random, but they will still be periodic, isn't it?
Yes, the resultant signal that you're going to get is still going to be periodic. Okay.
And
However,
if you could come up a bit,
if the amplitude is being is a function of time,
yes sir,
then it may not be periodic. और आपके अगर communication systems आप याद करें तो सारा का सारा वो यही करता है. Phase function of time होता है और amplitude भी function of time होता है. But that's not what we're doing yet. जब हम process करेंगे, that's what we're gonna do.
Okay, sir. And sir, if you could scroll up a bit, so जो एक case था कि A1 is a subset of A2, then the probability of A2 will be greater than A1.
बिल्कुल शुरू की बात है. This one.
So my internet connection is unstable. Yeah, so थोड़ा lag आएगा, so please bear with me on this. So if you could please kindly elaborate this with an example. I mean that's not very intuitively clear to me.
Okay, so let's say कि A1 जो है is the number of people who are less than 40 years of age. Oh, sorry. A1 is the event that the person is less than 40 years of age, and A2 is the event that the person is less than 60 years of age. ठीक है?
ठीक है, I get it.
किसकी probability ज़्यादा होगी?
Probability of A2 because जो 60 years से कम है वो 40 वाले भी जो है उसमें included है.
Exactly, and that's what I mean is one of the event is actually a subset of the other. Right? So the event A, if that's defined, A1 defined as less than 40 years of age, and A2 is defined as less than 60 years of age, then A1 is a subset of A2. Because if A1 happens, you know for sure that A2 has occurred as well, and A2 is satisfied as well. Okay? So therefore, A1 is a subset of A2.
Okay, sir. And last but not the least, if it's not a problem, kindly use a gray background just like this time because screen, we see ourselves in the screen reflection. Notes किसी भी उसमें it doesn't matter.
फिर से बताइएगा, फिर से कहिएगा.
Yeah. So I was saying कि अगर ये gray background हो सके because we see a reflection in our screen of ourselves in the screen. Notes किसी भी उसमें background में that doesn't matter.
Okay. So somebody yesterday said कि gray के बजाय black कर लें. I see that person smiling. So let me think about that. ठीक है शोएब? अभी इसको नोट्स में कन्वर्ट करने के लिए मुझे बड़ी जान जोखिम का काम करना है अभी.
I understand, sir.
The original plan I had failed. अच्छा जी, if the other questions, Maha, do you have a question? या पहले का हाथ खड़ा है?
सही पहले का ही है.
पहले का इसको नीचे कर लें, मैं कर देता हूँ. अली जैन, आपका भी हाथ खड़ा है. You have a question?
सर वो तो पहले किया था, लेकिन एक क्वेश्चन है मेरा.
हाँ जी बताइए.
सर ये मुझे ना एक बात नहीं समझ आई, जो इवेंट्स की डेफिनेशन आपने कराई थी उसकी जो एग्जांपल 3 है वो जरा प्लीज रिपीट कर दें.
इसमें क्या नहीं समझ आई कि देखें एक रैंडम एक्सपेरिमेंट है. जब रैंडम एक्सपेरिमेंट करते हैं तो थीटा की कोई वैल्यू आ जाती है. that's a randomness.
Yes.
Okay, an event would be that when I do the experiment, the phase turns out to have a magnitude which is less than pi by 4. That's an event.
Okay.
ठीक है? And the sample space is from minus pi to pi.
Okay.
ठीक है? ठीक है. हुज़ैफा?
सर मैंने पूछना था कि अभी हमने जैसा डिफाइन किया था टू इवेंट्स आर म्यूचुअली एक्सक्लूसिव देन दे कैन नॉट बी इंडिपेंडेंट. तो इफ अब जस्ट बाय लाइक प्रूफ मुझे वो थोड़ा सा कंफ्यूज करता है कि अगर इंडिपेंडेंट है तो हाउ डू वी प्रूव के इसका काउंटर, ये काउंटर वो तो नहीं होगा ना इसके?
तो आप जो वो इम्प्लीकेशन जो दूसरी पीछे आना चाह रहे हैं कि व्हाट यू वांट टू प्रूव इज कि इफ दे आर इंडिपेंडेंट you're saying that they cannot be mutually exclusive. Is that what you're saying?
सर डज दैट होल्ड या फिर हो सकता है वो फिर भी?
नहीं, that holds. That holds.
ओके,
By contradiction.
ठीक है।
देखिए मैं उसको इस तरह, आप इस तरह देख लें उसको कॉन्ट्रडिक्शन से। आपको पता है, अगर आपको ये पता है कि अगर दो इवेंट्स म्यूचुअली एक्सक्लूसिव है, वो इंडिपेंडेंट कभी नहीं हो सकते, ठीक है? तो अगर इंडिपेंडेंट है इसका मतलब म्यूचुअली एक्सक्लूसिव नहीं हो सकते। सो दैट्स देयर इज नो इम्प्लिक, वो वाला जो आप कंफ्यूजन कर रहे हैं ना, वो है नहीं असल में।
ओके, ठीक है।
इफ दे म्यूचुअली एक्सक्लूसिव इवेंट्स दे कैन नॉट बी इंडिपेंडेंट, ठीक है? तो इसका मतलब ये है कि आप इंडिपेंडेंट इवेंट्स पे चले जाएं तो वो म्यूचुअली एक्सक्लूसिव किसी तरीके से उसको इम्प्लाई नहीं कर सकता।
ओके सर,
ठीक है? उल्टा शायद आप अगर कुछ सोच रहे हैं तो वो कुछ और होता है, पर लेट मी थिंक अबाउट दैट एज वेल कि कौन से काउंटर एग्जांपल्स हम सोच सकते हैं। अच्छा, there's a question here, so I'm going to stop recording.